What's up, internet? In this video, we are going to understand asynchronous APIs in JavaScript. We will learn about why and how to use promises and async await APIs. So here in my project, I got a simple server. I'll execute this in the future, but for now, I'll explain what it's doing. So I'm going to open this server on port 3000, and it's going to handle one get call to root endpoint. When it receives a request, it's going to process it for 10 seconds. That's important. It's going to wait 10 seconds. After that, it will send the response back to the client. So I had to allow cross origin, otherwise I'll not be able to send a request from another origin. So that's why I'm using this middleware. Now I got a bunch of code snippets, and I got main file that's empty for now, and I got a index.html file in which I'm linking that main.js file. So let's start. Now let's open code snippet in the side, and I'm going to open main.file in this left window. So let's talk about synchronous APIs first. I'm going to first copy that line. Now this is a synchronous web API, get element by tag name, elements actually. So it's going to search for body tag in the DOM, and it's going to return whatever the element or elements found in the DOM to this variable. So this is completely synchronous. It's going to block the current thread. It's going to wait whatever this is to be completed, and it will get the return value from this method. Now, when I console log element list, is going to print the list, and this second console log will be executed after. First, in order to see this in action, I'll have to actually start live server. So yarn live server. Okay, we got 8080 port for whatever the file we want to host. So let's open index.js, and I'm going to open it on the Chrome browser. All right, now actually let me move this to the first window, and I'll open the console. Okay, now let's run whatever this is again. You can see it's returning this HTML collection, which is a output of this one right here, and it will console log out. This text will be executed in the same order they are being called. So this is a synchronous web API. Now let's pick a asynchronous web API. So there is a API available to JavaScript from the browser itself. So that's why they are called web APIs. They are not really part of the JavaScript standard library. So we got set timeout. It's going to take a number of milliseconds actually, and it's going to wait for that to be completed, and it will execute whatever the passed anonymous function after that time period. Now when I execute this one, you will see something weird. You can see it printed this 2 first and then printed 1 after. So what is going on? As I said, this is a synchronous API. Now when we call that, we will not know when this call is going to be completed. Let me actually explain things in a diagram. So we got a JavaScript runtime here, we got web APIs, and we got something called event loop. Now, when we first execute this JavaScript file, it's going to go line by line. First, it will find the set timeout call. So after JavaScript reading this call statement, it will realize this is a web API and that is a asynchronous web API. Now, in that case, JavaScript will send all these details, the callback function and 1000 milliseconds to Web API to process. Now, right now we are here, we are reading set timeout call. It will realize it's not belongs to JavaScript standard library. So it will send the call to Web APIs to process. So right now Web APIs are processing whatever the call sent from the JavaScript runtime. So right now JavaScript done executing this statement. So it will navigate to the next statement, which is this console log. So that's why it printed 2 to the console first before 1. You can see it printed this one first. So how did this one got printed to the console? Let me explain. As I said, right now set timeout is being processed in Web APIs or on the browser. Once that's done, it's going to send this callback right here back to event loop, something called event loop. So this is how JavaScript handle click events and stuff. So as I said, that this callback is going to be end up in the event loop. Now after executing everything in the stack in the JavaScript runtime, it's going to check the event loop for something to be executed. So it will ask for, is there something that should be executed by me? It will ask for event loop. Now it got this callback. Event loop send it back to JavaScript runtime. So now it's executing asynchronous method. As a result, it's going to console log out 1 into the console. So that's what's going on. I think you get the idea. So why not synchronous APIs, right? Why are we doing things asynchronously? If we had a synchronous APIs, synchronous set timeout, we should be able to do something like this, right? Set timeout, I'm going to pass 1000 milliseconds and it's going to wait for 1000 milliseconds. After that, it will execute 1 and after that 2. So why not that? Why are we using asynchronous APIs? Let me show you that. I'm going to get this third example. Okay. So here I'm capturing 3 elements from the DOM. I'm going to assign them into variables. I got one header tag and I got 2 buttons, increment and send request. I'll show them in the UI. This is the header. Actually, let me show you the DOM, and these are the 2 buttons. First one is going to increment the number, whatever this is going to increment the number. Second one is going to send a request. So if you want to actually check that out, the event listeners of this element, what you can do is you can select the element and go to event listeners, and you will find all the registered event listeners there. Right now we got this one right here. You can put a debug point and do all that, but let's go back. So for now, let me comment this line out. So previously I had them set to hidden, that's why those were not visible in the screen. Now I'm setting them to visible, and I have a count variable to keep track of the count, the number. I'm setting the count to initial count to 1, and I have registered 2 click event listeners to increment button and send request. These 2, increment and send request. The increment one will change the inner text dynamically when we are clicking on this one. It's going to increment the count and it will show that in the view. Now when we click on the request button, it's going to send a request to localhost 3000, the one I showed you earlier. Now there is one important thing. When we pass false into this open API, it's going to execute this one synchronously. Okay, it's going to execute this in synchronously. Okay, now I'm going to open a connection to this localhost 3000 root endpoint, and I'm going to send a request, and I will console log out the response. Now I'm going to save this. You can see when I click on the increment button, it's going to increment the count. But when let me actually clear the console. I'm right now in the network tab. I'm going to click on send request. You can see, actually I forgot to start the server. Let me do that quickly. Let's go into, actually I should be able to do from right here, server, src, and execute app.js file. Now we have started the server. Okay, now when I send the request, you can see it's pending right now. As I said, server is going to take the request, it's going to wait for 10 seconds, and after that it will send back the response. You can see now it got completed. Okay, as I said, I can click on increment button to increment the count, but when I send the request, after I send in the request, you can see it's right now pending. Now if I click on this one, you can, here I'm clicking, I think it's not going to update the view. So what the hell is going on? So when we send a request synchronously, JavaScript main thread is going to be blocked. So when we click on this increment button, it's not going to update the screen. You can see it failed to do so. Nothing is going to be working on the screen. The complete web page is frozen until whatever the response is getting back to the client. Imagine scrolling down on Facebook. If those calls were sent synchronously, we will have to scroll down. Then in the background, Facebook is going to send some request. We will have to wait for some time because the screen is frozen. And after the response is received, then again we can scroll down. So this is not going to be a good user experience, right? So that's exactly why these APIs are asynchronous, not synchronous. So by the way, everything in Java is synchronous, ran asynchronously. I don't know if they have asynchronous APIs now, but by default, they're going to be executed synchronously. So how do they handle them? Well, Java got multiple threads. They can create multiple threads, but JavaScript cannot. We got only one main thread for web page, and we will have to deal with all the requests, calls, and all that within that same JavaScript thread. So that's why these web APIs are implemented asynchronously, not synchronously. Okay, I think you get the idea why we need asynchronous calls. I'm going to put a little pause here. So somehow I forgot to show you the asynchronous example of this one. Um, I realized that while I'm editing the video, so I'm going to show you it now. Let's comment these lines, and I'm going, oops, I'm going to use the same thing, use the XHR um, APIs to send a request, but this time I'm passing false. Sorry, I'm passing true. When we pass false, it's going to execute that, send a request synchronously, but when we pass true, it's going to send it asynchronously. Now this time around, we have to pass a callback function, right? Because we are running stuff asynchronously, and we will have to there should be a way to handle the order of the execution. So we are passing this asynchronous function this time around, but before we just send it and read it in the console. All right, now let's see. I think you saw previously when we send the request, um, you know it's still pending, but when we send a request we cannot interact with the UI, but right now we can, because this API is asynchronous and it's allowing us to interact with the UI, because this is being processed in the web API or in the browser, not the JavaScript runtime right now, while this is in pending. So we can do interact with the UI. And I'm going to start the rest of the video from here. Now let's look at why callback functions. I don't know if you have noticed, but most of the time, I think almost always when we are calling a asynchronous function, we are passing a callback. So why is that important? Let me show you that. So right now I'm calling set timeout. It's going to wait for 1000 milliseconds. It's going to print console log 1 after that. Now in the execution, as I said, it's going to print 2 first, after that 1. So let's say I want to execute this one after this one is executed. So what do I do? Well, I will have to move this into the callback function itself. Otherwise, I cannot control the order of the execution. So that's why callback functions are important. If you want to control the order, do something after set timeout, in that case, we will have to have a way to execute that. So that's why we are always passing a callback function so that Web API can send it back to the event loop, and eventually it will end up in the JavaScript runtime. So we are controlling the order of the execution even though those APIs are asynchronous. Okay, to the next example. Let's talk about what is wrong with callbacks. So here I got this example where I'm calling set timeout multiple times, but each and every time I want to control the order of the execution. Now, first I want to wait for 200 milliseconds, and I'm going to console log whatever this is. And again, I want to wait for 200 milliseconds. Assume these are HTTP calls to a web server. This is really normal in a JavaScript application. We will have to send requests to web servers all the time. So we have to control the order of the execution. Let's say I want to get some users. After that, I'm going to send another request again. Things like that are normal. So in this case, I'm using set timeout, but you get the idea. I want to control the order of the execution. So I'm doing it multiple times. I'm going to wait 200 milliseconds each time after a console log. Okay, now when I execute this one, it's going to be executed in the same order, 1, 2, 3, 4. But I think you see something is wrong, right? It's going to, go like this. So there's something called callback health in JavaScript. Let me show you some images. Hell. So it's something like this. When we keep sending, asynchronous calls, we have to pass callbacks into them. And if we want to control the order, we will have to, nest a callback function inside a callback function. So we will end up in a something called callback hell, something like this. So this is not nice. This is not readable. It's so hard to, understand what the hell is going on. So because of this, because of callback hells, people have implemented something called a concept called promises. Now we are going to look into promises. So this is, I actually initially wanted to create a promises video for my Cypress automation tutorial series, but well, behavior is the same, but implementation is kind of different. So I created a separate video. So if someone wants to, in that someone following that Cypress course can come here and watch this, and I think they will start to understand what's going on in Cypress. They're using, they're executing commands asynchronously, and they're using promises. So this part is going to be important for you if you're using Cypress. All right, now let's do the same example. Let's do the same thing, but using promises. I'll comment this stuff. You can see I'm doing the same thing, But this time I'm using something called promise. Actually, let me get rid of this stuff. Okay, now first I'm creating a function. It's going to that function is going to take a time. So I'm wrapping set timeout asynchronous web API using promises. It's simple. All we have to do is create a new promise and return it from the whatever the function so that we can access it. And to the promise, we are going to pass an anonymous function. So the promise is going to pass resolve and reject methods. Those are methods, actually functions. We can use them in the whatever the call we are using, asynchronous call. So I'm directly passing this resolve function into set timeout. Previously we had let me we have passed an anonymous function, but this time I'm going to directly pass this resolve. So whenever this set timeout is completed, it's going to call this resolve method of the promise. Okay, now I got the time which passed to this function. So I'm calling post method, this one right here, like this, and I'm passing 200 milliseconds. Now I'm controlling the order but using something called then callback, then API. So this then API is going to take a function, anonymous function. Inside there we can do whatever we want. Right now we are console logging out 1, and this is important. I'm returning another post. I'm calling another post for 200 milliseconds, and I'm returning it. This is important, really important. If you want to wait for this to happen, always you will have to return it. Otherwise, this post 200 will start another asynchronous function that cannot be controlled by this first promise. I think you see the difference, right? When we are using promises, we don't have callback else. We just attaching, this is something like a chain. It doesn't matter how many asynchronous calls we got, we can control it in a readable fashion than this one right here when you are using callbacks and stuff. So that's why promises are introduced into JavaScript, and that's why we are using them. We don't want callback else in our application, because it's so hard to read them. Um, it's so hard to read them and figure out what's going on if developer wants to come back to the code and change something. So I'm not going to go into promises deep, but maybe I will create another video. I just want you to understand the asynchronous behavior, why we are using promises. Now you know. So promises were not good enough, apparently. Even though promises are controlling the order of the execution, a kind of a readable manner, it's not that readable. Um, so JavaScript people wanted to do better. So that's why they introduced something called async await APIs. So now let's look at async await APIs. I don't know if I can call them APIs, but whatever. So let's copy this one, and so it's going to be something like this. We are doing the same thing we did using promises and these callbacks, but this time it's kind of easy to read. Now when we are using async await, there's a rule we need to follow. That is, in order to use this await keyword, we will have to define whatever the thing inside a async function. Otherwise this is not going to work. So always use await keyword inside a async, otherwise you will run into errors. But I think Deno, I don't know if you have heard Deno. The same guy created Node.js, created something called Deno with built-in TypeScript support and stuff, some security stuff too. So in that in demo you can call await without creating a method, so that's kind of nice. But we will have to create a method on Node and web browser. So here I'm creating a anonymous function, async anonymous function, and I'm assigning it to do something variable, and I'm calling it here. Now, since we are in async anonymous function, we should be able to use await keyword. Now I'm calling pause. Actually, I'll have to copy this one, otherwise there is no something called pause in the current context. Okay, you can see we are using the same promise, right? Remember, we wrapped this set timeout in a promise when you're using this promise chain. I'm using the same thing, but the syntax is different when you are calling them. So await is going to wait for this promise to complete, and only after that it will execute the next statement. So it's going to control the order that way, and this is so easy to read. Now let's see that in action. You can see it's going to print 1 2 3 4. Let me reload that. 1 2 3 4, like that. So I think this is the best way you can control the order of the execution of async APIs, async calls. Browser support is there for Chrome and Firefox, probably for Opera as well. I don't know, people are using that, but probably I don't know if this is working on IE 11 or something. I don't know why people are using IE anyway. So somehow this is the latest API for handling asynchronous calls, and that's the story of how we end up in callbacks to promises to async await in JavaScript. Before I'm ending this video, let me add something to Cypress people who are watching this video. So let me copy this one again. So assume this pause is a Cypress command, and I think you are familiar with then command is Cypress. So those chains are, command chains are, we are doing get on cy, then we are typing, clicking and stuff. Those are ran asynchronously, just like this promise. So that's why the order of the execution is so important. That's why we are not directly assigning, let's say, whatever the return value to a variable, because that's in that case it's going to be a new promise object, or in Cypress it's going to be a chain object, not the actual value you are expecting. And let's say I broke the chain and I'm going to console log something, hello world. If I do this, this hello world is going to be executed first, because it's the same reason as this one, because the call, whatever the async web API is going to be sent to the browser to process, this one right here, and it will go back to the event loop and eventually end up in JavaScript runtime. So if I try to do something like this, first Cypress will execute whatever this thing, and it will send, actually it's going to send this first one to event loop first. Meanwhile, Cypress will execute this console log. So we will get the hello world first, then after that 1 2 3 4 in the same order. So you can see we got the hello world 1 2 3 4. So that's why it's important to follow or the control the order of the execution when we are dealing with Cypress commands. I hope you understood how, basically any asynchronous API working on a web browser or any JavaScript runtime. So this is it for this video. Thanks for watching. Have a nice day.